We just finished talking about factorials. Factorials is a mathematical tool that we're going to be using in the next couple of videos as we talk about permutations and combinations. Now we've actually seen permutations already. If we go back to the last thing that we talked about with factorials, we asked how many ways can 13 runners run in a race? How many ways can they finish between first and last place? So a permutation is just the different ways that they can be ordered. How many different ways can they finish between first and last place? We're going to dive a little deeper here. Specifically, instead of talking about how many ways can these runners finish first to last, we're going to say all we care about are the first three places. Generally, when people run a race, all we care about is first, second, and third place. Fourth place and on, great, good for them. We pat them on the back, but there's nothing special specifically about those places. They don't get any awards. The awards go to first, second, and third place. So how many ways can 13 runners cross the finish line in first, second, and third place? Well, hopefully you can figure this one out already. There are 13 different ways that runners can finish first place, 12 different ways they can finish in second, and 11 in third place. And we don't even worry about the rest because this is all we worry about, all we need to answer. So if we're using the fundamental counting rule, that's 13 times 12 times 11, which is 1,716. But I want to expand this equation a little bit, okay, so that we can see something. If I turn this into a factorial, which is what we saw in our last video, essentially what we have is 13 factorial, all numbers from 13 down to 1 multiplied together, but we removed everything from 1 to 10. Okay, if everything's multiplied together, how do you remove a number? Well, you divide by those numbers. That's how you get rid of them. Okay, so we have 13 factorial on the top divided by 10 factorial on the bottom. What does that do? Well, that takes all of these extra numbers and it cancels them out and they just go away. Okay, so 13 factorial divided by 10 factorial just gives us 13 times 12 times 11. We want to keep the factorials right now, though, right? Now, I'm going to expand it one more time. Where did the 10 come from? We have 13 factorial, and we know that so 13 runners, that's where the 13 factorial comes from. And we're talking about the first three places, first, second, and third places. So we have 13 and we have 3. Where does 10 come from? Well, hey, 10 is just 13 minus 3. So this is going to be 13 factorial divided by 13 minus 3 factorial. Okay, so we took a simple problem and we made it more complicated. The reason I did that is because this is the official formula for permutations. To find a permutation where n is the number of subjects you're dealing with and r is the number of places you're trying to fill, then then the permutation is going to be n factorial divided by n minus r factorial. And that's what we just saw. This would be written as 13 permutation 3. Okay, so we're doing a permutation of 13 people, selecting just 3. And that's going to be 13 factorial divided by 13 minus 3 factorial. All right, that's where it comes from. Honestly, this functions in your calculator. I want you to understand where this came from and what it's doing. A permutation is just taking the total number of subjects you have and looking at how many ways they can finish in the first R different spots in your scenario. Okay, a couple of notes. Different arrangements of the same items count as different permutations, meaning the order in which they are selected matters. For example, A, B, and C are not the same thing as C, B, and A. Okay? And this really makes sense if we go back to our race of 13 people. How many ways can they finish first, second, and third? Well, if I finish in first place and the next two people finish second and third, that's a very different result from if I switch myself in the second place winner. Then he would have first place and I'd have second place. It's a very different result. I no longer have first place. So with permutations, the order in which they are selected matters. Okay, let's do another example with this. There's a NASA grant that's out there, and we're getting applicants for it. They're offering a prize for the first 5 successful entries for a new radio communication system. The first successful entry will receive $50,000. The second will receive $40,000. The third will receive $30,000. The fourth will receive $20,000, and the fifth will receive $10,000. Okay? Now, if you have 20 companies that are working towards getting this prize, they submit applications, they make entries. How many different ways can these 20 companies be sorted? How many ways can these 20 companies win these first 5 successful entries? Okay, this is a permutation problem. We have 20 entries, and we're selecting the first 5 successful entries. So this would be a permutation of 20. There are 20 ways that the first person can be successful. There are 20 different companies that can successfully get first place. There we go. After they get first place, there are 19 companies left. So there are 19 different ways that they can select second place. 18 different companies that can get third place, 17 that can get fourth, and 16 that can get fifth place. Okay? I'm putting up this calculation so that you can see it right off the bat, logically. Now let's do it with the permutation equation. So we have 20 companies, and we're selecting the first 5. And the order matters, so we're going to do a permutation. That will be 20 factorial divided by 20 minus 5 factorial. 20 minus 5 is just 15. So it's 20 factorial over 15 factorial. And yes, when you spread that all out, then you just get 20 times 19 times 18 times 17 times 16, which we've already done. But if you put in a calculator, sure enough, they're going to give you the same answer of 1,860,480 different ways that these 20 companies can be organized, or that these 20 companies can finish in first, second, third, fourth, and fifth places.